You a couple things about JMP. First of all, I've got this data on the consonance and dissonance that I prepared in Google Sheets. I always recommend starting with Google Sheets before going into a statistical analysis program like JMP. I use Google Sheets with the VLOOKUP function over here to add all of the data about the participant demographics. So you can see how in this um, sheet you've got the gender, nationality, musical background, etc., etc. And I needed to add that to this data about the participant ratings of, for instance, the pleasantness of the frequencies. And so I added the data over here using this VLOOKUP function. It's honestly a bit of a bitch, but this is an example of how I did it. Anyway, let's get back to jump. That's what I want to focus on. So in jump, the first thing that I notice is that there are European commas for periods, which is the only thing about European numerical metric systems that I think is really annoying. But so I need to change that. So I do a find and replace with the comma and the period by column, and I replace all. Okay, great. I'm going to do the same thing over here. Oh, look, it already did that. Um, so now, what's my intention? I want to come back over here and do some distributions. Distributions are where I always recommend starting with. And I'll throw those like this. And now I can see that everything's pretty normal. I do want to know what's going on over here. I feel like that's not correct. You'll notice these. This is going to mess up our functions. That must be 80.803. So actually what I'm going to do is I'm going to go back to the main table and just make those changes right now. So bottom frequency, let's see if this happened over here. Oh yeah, it did happen over here with the middle frequency. So bottom frequency, I'm going to recode, and I'm going to make this 80.803. Oh, did I put a comma in there? No. Okay. Oh, I did. Damn it. Okay. So now all of these are good. Recode. And I'm going to do the same thing for middle frequency. Recode. And change that to a period. 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 Okay, good, 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 good. This is all where I want it to be. Now what about the top frequency? That's cool. So all this is good. So I'm going to run these again. Analyze distributions. Throw everything in there. And we're good. Great. I thought I changed that. Oh, right. So when you recode, it does this this thing where it'll create a new column unless you change it. So I'm going to come back over here. I'm going to delete this column. I'm going to delete this column, and I'm going to rename this one because I meant to make it the same column, but I didn't. Okay. And then once again, I come over here and I say analyze distribution, select all, Command A. And what do I see? Okay, good, good, good. Those all look right. Pleasant. Oh, people did not like these frequencies. So this is not normally distributed, but this is okay distributed. This really won't interfere with your statistical analyses. Interesting that they put so much here for monotone. So the difference between, okay, here's one thing I want to see right off the bat. So if I've got a 0 imperfect, yeah, they see this as much more monotone. If I have it over here, it's much less monotone. That's more or less what we're expecting. Jump is a cool program that you can do this, right? I think so. So this is very dissonant. People don't like it very much. Though, look, some people really like dissonance. Interesting personality characteristic, huh? I like dissonance, so, well, I like harmony. Okay, back on track. Good, you've got some non-binaries in here someplace. Now, always what you're doing, like there's no process to this. You're just trying to see stuff that's weird and then see what's going on. So, okay, did you ask for age? Yes, so of course the oldest person is going to have the most musical experience. Age and how many years will interact with each other. Therefore, if you're using it in distribution, so you should include both. Great. Okay, so done with distributions. Some of these can be included in your final report, like these. These ones can be included. Okay, let's go back and then let's do the model fitting right off the bat because no, let's do this multivariate. So what this is when you want to look at multiple variables. I should just say multiple variables. So, oh, and I'm noticing these, the whole point of making those changes with the commas and the periods was to turn these into continuous variables. These are set up right now as nominal variables instead of continuous. So I'm going to go back over here. I'm going to change it. Oh, can't do it that way. But if I come over here, column info, I'm right-clicking, column info, and then I change this to numeric, continuous. It treated it like a string because it had a comma in it, right? Numeric, continuous. Okay, good. So now, I wanted to look at all of the different variables. We've got, ooh, also this one. Why is this a string? Shouldn't be. Column info, character, numeric, continuous. Okay. Right. So, I'm going to look at all of our continuous variables here. Okay, so now I can see this correlation table between all of the variables. Here's one of the main things we want to look at is pleasant versus these other things that people rated, like monotone and happy. And pleasant against monotone. That's a fair correlation, but it's not very strong. And happy. Oh, there we go. Okay, interesting that happy and pleasant are not correlating higher than this, but you know that's still a pretty high correlation, probably higher than anything else we'll see, except for these things in the design factors. Okay, so neat, whatever. Anything about years? How many years people have studied music? Not really seeing anything there. Okay, whatever. So now I'll go to fit model, and I want to see how things relate to pleasantness, and I'll look at all of these things, these are the design factors. This is what goes into it. I'm gonna look at gender, I'll look at age. Wait a minute, why do I have gender in here twice? And gender as a continuous variable. Right. Okay, I'm gonna get rid of this one. Delete. Okay, right. So I'm gonna put in gender, age, how many years of musical background, preferred genre, and the top frequency, because I believe from the distributions, the top frequency was the one that changed consistently, right? So I'm not going to look at these other ones. I'm only going to look at the top frequency and the percentage of imperfection. And I'm going to use this macro here of the full factorial. This might break things, but I want to look at it all. Actually, instead of doing that, just because I don't want to break things, I'm going to say the factorial to degree. Okay. Yeah. That way I won't get like all of the interactions between everything, but I'll look at the interaction. Yeah, I won't even explain this. Okay, let's see what we got. Oh, okay. So how many years of musical experience and the preferred genre had a huge effect on how pleasant people see things, which is not what I think. Now, this isn't a great model. This is not showing things so strongly, but whatever. We'll ignore that for now. These preferred genres are really intersecting. Okay, but I don't really trust this right now. It's kind of interesting, blah, blah, blah. But let's look at the main thing we want to see, which is how pleasantness is predicted by the imperfection and the bass tone. I think that's the main thing that you're looking at. And I'm going to use this response surface thing, which multiplies the top frequency and it multiplies the continuous variables by themselves, which if you remember from, I don't know, what was it, calculus, like x squared is a curve, right? Like x is a line, but if it's x squared, then it's a curve. And so we're going to look for curvature, which we know exists in this. So I'm going to just see this, and it is not seeing curvature. Oh, no, it is. It is seeing curvature in the percentage of imperfection, which we'd expect because that's what you saw in your graphs. And I want to look at this profiler. Yeah, check this out. These are this is what you saw before. So there's not much of an effective frequency, which we'd expect. The highs and the lows are preferred a little bit less than what's in the middle. This is what we estimate for the ideal imperfection, which is about 5%. Yeah, this is super interesting, man. Right? It's super cool. So, that's important. We'll save this one just so you've got it to the data table. Okay, blah, blah, blah. What else do I want to see? Oh, I want to graph this stuff. This is really where I should have started. I wanted to look at those models, but let's start graphing stuff. So the outcome variables that we care about are pleasant And we're looking at this percentage of imperfection. Now, other things that we want to see are how monotone things are, how happy things are, okay, and I could turn this into a log scale. Let's see if that does anything interesting. It just spreads things out. That's sort of my intention there. People don't find things very pleasant in this, which is not super surprising. And just adjusting things so I can see this curvature a little bit better. Now, I can make it like this instead and make it a quadratic. So it's got curvature, but see, that doesn't really help. So whatever, I'm actually just going to get rid of this entirely. And what else do I want to see? What else would be interesting? Gender? Okay, so the other, we don't have much data there. This smoother thing I don't really trust. So I'm going to go back to the bar charts. Or I could even do the line charts. That's probably the way to go. Yeah, that's cool. And I'm going to add these error bars in just because it's going to let me see stuff a little bit better. Maybe there's a gender effect. There's usually some kind of gender effect. Okay, right. Error bars, line, error bars, standard error, line, error bars, standard error, line, error bars, standard, oops, line, error bars, standard error. I'm going to get rid of the non-binary here only because it's, well, no, that would be not inclusive. But there's only one data point, so it doesn't say anything about the others. So, what do we see here? Males are finding things more pleasant than the females and happier, but they don't differ on monotone. But that's, it looks like it's significant. So usually if error bars are not overlapping, then that means that it's different. Okay, look, what time are we at here? I'm going to end this because we're almost at 20 minutes, but I hope you've learned how to use jump, and I hope that's interesting. Bye-bye.